Hello there, this is Harshika and I'm studying at grade 10 in Imperial World School. Today I'll be presenting about the Pascal's law. If you're studying in grade 10, you may be quite aware about the Pascal's law. Pascal's law states that when pressure is applied on a liquid in an enclosed vessel, the pressure transfers equally in all directions. For example, we have this beaker here. Let us suppose that this is an enclosed vessel. Now, we have a liquid inside this, and the liquid that's present inside here exerts equal pressure in all the walls of this beaker. This model is made with the help of Pascal's law. In this model, we have two syringes. So here, let us suppose this syringe to be syringe 1 and this syringe to be syringe 2. So we have syringe 1 and syringe 2. Let this syringe have a cross-sectional area of A1, which means that syringe 1 has a cross-sectional area of A1 and syringe 2 has a cross-sectional area of A2. Now, if I apply a pressure of F1, a force of F1, then syringe 2 comes down with the help of force 2, which means that syringe 1 has a force of force 1 and syringe 2 has a force of force 2. Now, according to Pascal's law, force 1 by area 1 should equal to force 2 by A2. Some applications of Pascal's law are hydraulic press, hydraulic brake, and hydraulic lifts. Now here, let's take an example. We know that Pascal's law is a force multiplier. So let's take an example of a hydraulic lift. Here, if I have a piston having cross-sectional area 2 meters square and another bigger piston having a cross-sectional area of 100 meters square, and if I apply a pressure of 10 Newton on this piston, then according to Pascal's law, I'm supposed to get 10 Newton by 2 meters square equals to force 2 by 100 meters square. After equating the numbers, I get that force 2 equals to 500 Newton. Now, with just the force of 10 Newton, I've multiplied this force to 500 Newton, which tells us that Pascal's law is truly a force multiplier. I hope you got something out of today's lesson. Thank you.